So we're looking pretty good so far. We've got our bird who moves in the way that we want him to, and we've got our tubes which repeat forever and are randomly given heights so that they makes it quite difficult to get the bird through them. So our next challenge is to work out how to do collision detection. So we want to take our bird and make it so that when he or she bumps into a pipe, that the game is over. So let's do that. But first, there is just one small hitch that I've noticed, and that is that we want the tube offset to be reset whenever the tube moves to the right of the screen. So when we do that jump, we want the tubes to be in a different place. And at the moment, you can see we've just got the same 4 locations repeating again and again, which is not what we want. So very easy. We just add the tube offset creator over here as well. Right. So how do we do collision detection? Well, essentially what we need to do is create shapes for our bird and our rectangles so that we know where they are in space, and then we look using GDX for a collision between those shapes. So let's start off by creating a shape for the bird, and a pretty good approximation to the shape of the bird is a circle. So I'm going to create a circle for the shape of the bird, which is just going to overlap on top of the bird essentially. So let's create that up here, and this is going to be a circle. I'll call it bird circle. And this is going to be a new circle, if I can spell it right. And then we just want to create a circle that overlaps where the bird is. So it's going to be quite similar to this, but instead of using a batch, we're going to use a shape renderer. In fact, we'll create our shape renderer up here. So a shape renderer called shape renderer, which is a new shape renderer. So you should think of this just like a batch. It enables us to draw shapes. But batches just draw textures, and we can't do collision detection directly on textures. We need to do collision detection on shapes. So let's do that down here. So shape renderer dot begin, just as before. And this time we're going to specify a type of shape, and all our shapes are going to be filled in. So we use shape renderer dot shape type dot filled. You can see there's a few other options there that you can imagine you might want in a different situation. Then for now, we're going to have a color as well. So that we can see that our shapes are all in the right place. I'd use the GDX versions of those whenever you get the choice. And then we're going to take our bird circle and set it up to match the actual bird itself. So we use bird circle.set, and we're going to set the center of the circle. So that's going to be just the center of the screen and the X coordinate. So GDX dot graphics dot get width over 2. The Y coordinate is going to be bird Y, but remember bird Y is the Y coordinate of the bottom of the bird. So we need to add half of the height of the bird to get the center of the circle. So we want birds flap state dot get height over 2. And then the radius of the circle we also want to be birds.flapstate.getHeight over 2. Or we can use height or width, it doesn't really matter. The width is slightly bigger than the height. So I'm going to go for width. So this will give us the center of the circle, the x coordinate of the center of where the bird is, the y coordinate of the center of where the bird is, and then the radius of the bird, so the distance from the center of the bird to the edge of the bird, which we'll just approximate as half of the width. I've got a couple of brief problems as well. First, I spelled circle wrong. And I also think I've brought in the wrong circle class. So yeah, you can see I've chosen Java FX there. That's definitely not the one I want. So we definitely want, as I mentioned earlier, we always want the bad logic ones, the GDX ones. Okay. Lovely. So now I can set that correctly. Great. And I can now take my shape renderer and render a circle. And I'm going to get the X, Y, and radius from my bird circle. So it's just birdcircle.x, birdcircle.y, and birdcircle.radius. There we go. And then shape renderer.end. Lovely. So now we should find we have a red circle on top of our bird all the time. Obviously, we're not going to have that there permanently, but it will just show us that our bird circle is in the right place. I'm actually just going to move that up to the top. I think it makes a little more sense there. There we go. And just before we run that, there is one or two actual small changes we need to make. We need to create our shape renderer and our circle down here in the create method. It won't like it if we try and create it in the general class. So I'll just copy those instructions down and then remove them from here. Okay. So now we should find that we've got a big red circle on top of our bird, and that red circle moves exactly with our bird, and we can use that red circle for collision detection. Obviously, we're going to remove the actual appearance of the circle when we're done testing, but for now, there we go. There's our circle, and you can see it moves in a sort of slightly odd way there alongside our bird. Wonderful. So a challenge for you now. You're going to need to create a rectangle this time, not a circle. So it works in exactly the same way, but it's a rectangle rather than a circle. And I want your rectangles to be on top of the pipes. So for each set of pipes, you're going to need to create a rectangle at the top and a rectangle at the bottom. And for now, make them red and make them go over the top. I'm not going to worry about the slight sort of shape there. You might want to create 2 rectangles for each pipe if you want to be super accurate. But to be honest, if the bird is there, it's going to be dead anyway. So I'm just going to create 1 rectangle for each pipe. Okay, best of luck then. Go for it. Okay, that was a fairly big challenge. I hope you managed to at least give it a shot. We're going to need 4 rectangles at the top and 4 at the bottom. So I'm going to create an array of rectangles. And let's make sure I choose the right one this time. So bad logic, there it is. So an array of rectangles called top tube rectangles. And another array of rectangles called bottom tube rectangles. And then I'll define them down here with my tube stuff. So top tube rectangles is going to be a new array of rectangles, and there's going to be 4 of them in it, but I don't want to use 4, I want to use number of tubes. And exactly the same for bottom tube rectangles. It's going to be a new array of rectangles, and there's going to be number of tube objects in there. And then for each of those, we're going to define the rectangle to be a new rectangle. So we'll just take top tube rectangles I is a new rectangle. And the same for bottom tube rectangles I is a new rectangle. And that will just mean that everything's correctly initialized in the create method, and then we'll actually add the correct location of the rectangles down here. So we can do that here. And it's going to be very similar to drawing the rectangle, to drawing the tube, sorry. It's just going to be creating a rectangle for each one which overlaps the tube graphic itself. So let's create top tube rectangles I. And that's going to be a new rectangle. And we create rectangles. So if I can get the predict there for us. Nope. But the simplest way is to use an X and Y coordinate of the bottom left, and then the width and the height. So the X and Y coordinate of the bottom left are going to be exactly the same as the X and Y coordinate of the bottom left of the tube. And then the width of the rectangle is going to be the same as the width of top tube. So that's just top tube dot get width. And the height is going to be the same as the height of top tube. So top tube dot get height. And I think I actually missed there the X coordinate. I've only got the Y coordinate. So let's pop that in. Tube X I. So we've got the X coordinate, the Y coordinate, the width, and the height. And then, as you can imagine, bottom tube rectangles I is also going to be a new rectangle using tube X I again. And then the Y coordinate is going to be the same as the Y coordinate of the bottom tube. And then width and height, as before, is just going to be bottom tube dot get width and bottom tube dot get height. There we go. So with any luck, those rectangles should overlap exactly the existing tubes. So now it's just a matter of displaying them. So remember, we're only displaying them so that we can be sure temporarily that they're in the right place. We won't need to display them in the real thing. So we'll actually delete this code later on, but it will be useful for us now. I'm actually going to copy the for loop again. So each time we loop through, we want to take our shape renderer and render a rectangle, and we've got X, Y, width and height again. So we can get those straight from here because it's exactly the same as what we had. And in fact, we want to copy and paste them because we want to be sure that the red rectangles that we're displaying are exactly the same as the rectangles that we created. Okay, so let's have a look. We should now have red rectangles on top of all of the tubes as they move from right to left. Okay, this is looking good. We've got a red rectangle already. And there we go. So wonderful. Now we're playing a game with no sprites, just rectangles and circles. But now we can do our collision detection. And this, now that we've got our rectangles and circles, this is super easy. So let's do this after the shape renderer. Or actually, I'm going to do it in this loop here, because we need a loop anyway. We need to check whether the circle is colliding with any of the tubes. So our check is if, and then there's a GDX method called intersector, or GDS class, sorry, called intersector, which obviously we use to intersect things. And we want intersector dot overlaps. And then you can see we can overlap circles and rectangles, circles and circles, or rectangles and rectangles. So we want to overlap bird circle and top tube rectangles I, or well, we don't want to overlap them, but we want to test whether they are overlapped. And we want to do the same with bottom rectangles as well. So intersector dot overlaps bird circle and bottom tube rectangles I. And for now, we'll just log gdx.app.log collision. Yes. And it's as simple as that. So we should now be able to detect whether the bird has collided with any of the rectangles. And if it has, we'll get this log in the logs. So let's take a look. So here we go. Start playing, and you can see there, if I try and get through this one, I fail, and you can see the new collisions wonderfully appearing there. Brilliant. So now we've got our collision detection. It's going on merrily there. So now we no longer need our shape renderer. So I'm actually going to get rid of all our shape renderer code. I think I'll actually just comment it out so that you can still view it later if you want. But the point is we don't need it. And so let's just make sure that without the shape renderer code, this works in exactly the same way, except we get the actual game's graphics rather than the rectangles and circles. Just to keep things neat as well, I'll comment out the shape renderer code up here. Okay, here we go. So now we're playing along merrily. Let's see and just make sure that we're still getting the collision detection. There we go. So no collisions, lots of collisions, no collisions, lots of collisions, etc. Brilliant. So one small change before we finish this video. I'm going to get rid of the fact that the initial tube, you'll remember, starts off in the middle. We don't want that to be the case. We want it to start off on the right of the screen. So I'm going to add to that gdx.getWidth, .graphics.getWidth. And that will mean that the first tube starts off on the right of the screen as we want, and then it will just come into the screen. Brilliant. So we've got our collision detection. We're pretty much done. All we need now is a kind of game management system. So we want to display the score, and we want to start and stop the game when the user dies. So we'll deal with the first of those two, the score, in the next video. See you there.